All right, we are going to take a look at graphing systems of linear inequalities. So yesterday we looked at graphing one linear inequality. Now we're going to take a look when we have two or more linear inequalities on the same graph. Our steps are going to graph each inequality in the system using the same method as yesterday, and then you're going to identify the region that is in common to both graphs, so where the shaded regions overlap. Our first equation, we have y is greater than 1. So we're going to graph that boundary line. Think of it as y is equal to 1. And since we just have a greater than sign, it's going to be a dashed boundary line. So at the y value 1, we're going to have a dashed line. And then we're going to take a look at where we would shade for that particular line. So I'm going to test 0, 0. Once again, it doesn't lie on the boundary line, so I can test it. So I'll get 0 is greater than 1, which is false. So I'm shading on the other side. So I'll be shading up. And one thing when you're graphing linear inequality systems, you want to shade in two different directions. So this one I'm just going to go up. Or you can use different colors. That works as well. Okay, the next line is y is less than or equal to 3. So keep in mind, graph that as y is equal to 3. It's going to be a solid line since it has that equal to part. So at the y value 3, we will have a solid line. And then, once again, I'm going to use the test point 0, 0, since that does not lie on the boundary line. It lies beneath it. So we get 0 is less than or equal to 3. So 0 is less than or equal to 3. That's a true statement. So 0, 0 is a solution. So we're going to shade below that boundary line. And I'm going to shade horizontal here. All right, so we have the two solutions for our inequalities, but since we're graphing a system, the solution is going to be where the shaded regions overlap. And for this particular linear inequality system, they overlap in between the two lines. So this section that's shaded is going to be a solution to our linear system. All right, let's take a look at another one. So we have x is less than 3. Once again, you're graphing that as x is equal to 3, and it's going to be a dashed line. So at the x value 3, it's vertical. We're going to have a dashed line. And keep in mind, we're going to test 0, 0 since it doesn't lie on that. And we get 0 is less than 3, which is true. So we're shading to include 0, 0. So we're shading to the left of this boundary line. And I'm going to use a different color to illustrate the other one, just to give you a visual on that method. So using two different colors as opposed to two different directions. So either way is fine, but it's just another method you can use. All right, so this next line we are looking at, I'm going to choose, we'll use magenta. So we're graphing y equals 4. So it's going to be a horizontal line, the y value 4. It's going to be dashed once again since we have the less than sign. And we're going to take a look at testing. Once again, I'm going to test 0, 0. So we get 0 is less than 4, which is true. 0 is less than 4. So we're shading below the boundary line to include the point 0, 0. And once again, I'm using a different color just so the region that they both share will be a little bit more evident. So that's another strategy you can use, is using a different color as opposed to a different shading region. So this rectangle area beneath here is where the shaded regions overlap. So that will be the solution of our linear system. You'll see a lot of people use colors like blue and yellow, and so that shaded region will be green. So that's another strategy you can use as well, colors that will create a different color. All right, let's go back to blue. All right, the next problem we have is y is less than or equal to negative x minus 1. So we're graphing as y equals negative x minus 1. So we have a y-intercept at negative 1. A slope of negative 1 over 1, to go down 1 to the right 1, up 1 to the left 1. It's going to be a solid line due to that equal to part in the inequality. And then we're looking at where to shade. So we're going to test once again 0, 0. So we get 0 is less than or equal. It's going to be 0 minus 1. 0 is less than or equal to negative 1, which is false. So this one we're shading 0, 0 is here, so we're shading on the other side. So we're shading to the left. Oops. Okay. Move that. All right. Move that there. Okay. And the next line we are shading or graphing y equals 1/2 x minus 1. So we're going to have the same y-axis, except this time we're going to go up 1 to the right 2 units, up 1 to the right 2 units. And this is also going to be a solid line since it's a less than or equal to inequality. And once again, we're going to test 0, 0. Since it doesn't lie on the boundary line, we can test that. And we'll get 0 is less than or equal to negative 1, which is false. So we're shading on the other side. And once again, I like using that different color. I think it's a little easier to see where the shaded regions overlap. So they overlap in this region. So that's our solution to our linear system. All right. We're going to take a look at one more problem, and this one we are going to have to manipulate the system. So we have 3x plus 2y is greater than or equal to 8. So first we're going to subtract 3x from both sides. So we'll get 2y is greater than or equal to negative 3x plus 8. Then divide both sides by 2. So we get the inequality y is greater than or equal to negative 3/2 x plus 4. So keep in mind that's going to be a solid line. We're graphing as y equals negative 3/2 x plus 4. So we'll y-intercept at 4. Then we have a slope of negative 3 over 2. So we're going to go down 1, 2, 3 to the right 2. And then also up 3, 1, 2, 3 to the left 2. Solid line. And then we're testing 0, 0. And you can put that back into the original equation or the one you changed. So either one's fine. I'm going to choose the original because they're going to cancel out pretty nicely. Because that'll be 0 plus 0, because anything times 0 is 0. So we'll get 0 is greater than or equal to 8, which is false. So 0, 0 is not a solution. So we're shading on the other side. And for the next one, I'm going to use the color. We'll go back to blue. So first we're going to subtract 2x from both sides. So we get negative y is less than negative 2x minus 1. Then we're dividing both sides by negative 1, but since we're dividing by a negative number, the sign will flip. So this will become y is greater than positive 2x plus 1. So we're going to have a dashed line with a y-intercept at 1 and a slope of 2 over 1. So we'll go up to over 1, or we can go down to the left 1. And we have a dashed line. And once again, we're going to test. I'm going to test 0, 0 since it doesn't lie on the boundary line. So we're good to go there. I'm going to use the original. So it'll give me 0 is less than negative 1, which is false. So 0, 0 is not a solution. So we're shading on the opposite side. And keep in mind, I'm shading this one in blue. And the solution to our linear system will be where they overlap. So it's going to be this upper section here. All right, so that is graphing linear systems that are in the form of an inequality. I will see you tomorrow.